Hello friends. So as you have seen in a lot of sessions now, we have been going through in-depth analysis of the torque slip characteristics. We derived the actual equation of the different equations like torque induced, maximum torque, slip at maximum torque, etc. And then in the previous session, we have derived some approximate torque equations as well. Now let us put a small break for all these things and we'll do some numericals in this session so that you get a small break now, and after that we can continue our discussion on the torque slip characteristics. Okay. So today we are going to do some numericals on losses and efficiency of the induction motor. These topics are very important because usually in competitive exam, especially in objective questions, these types of numericals can be asked. Okay. So let us go for the first numerical. So what they are telling is that the power input to a three-phase 50 Hz induction motor is 60 kilowatts. So the power input is 60 kilowatts. The total stator copper loss is 1000 watts. Total stator loss is 1000 watts. Okay, that means it includes both the stator copper loss as well as the stator core loss, or in general the core loss of the machine. So you have to find what is the total mechanical power developed if the rotor EMF makes 120 complete cycles in a minute. Okay, so we'll just look at this numerical a little bit closer. Before that, just write down what we know. So the power input is given as 60 watts, 60 kilowatts, right? And the total stator loss, okay, the total stator loss is given as 1000 watts, or we can write it as 1 kilowatt. You have to find the total mechanical power developed. Now, total mechanical power developed is actually the converted power of the induction motor, okay? And the if they ask what is the output power, okay, or the shaft power, you will have to find this converted power and subtract the friction and windage loss. But in this problem, they are asking you to find total mechanical power developed. So it is P converted. Some problems they can ask gross mechanical power developed. Okay, so gross mechanical power developed, total mechanical power developed, and power converted are usually the same thing. Okay, and they are given the rotor EMF makes 120 complete cycles in a minute. Okay. So what it's telling is that the rotor, they are giving information about the frequency of the rotor induced EMF. So what they are telling, in 1 minute, it has 120 cycles, right? 1 minute in the rotor EMF, in 1 minute has 120 cycles, right? That means in 60 seconds, it has 120 cycles. But the frequency unit is per second, right? This is in 60 seconds. So per second, this value will be 120 divided by 60 cycles per second. Okay, so in 60 seconds it's 120 cycles, therefore in 1 second it will be 2 cycles per second. 2 cycles per second. And this is the rotor EMF, right? So this is the frequency of the rotor, which is 2 cycles per second or 2 Hz. Okay, so this is the information they have given here. So what you have to find? You have to find the converted power. Okay, now you know that the converted power formula, what we have learned as of now, see, they have not given any rotor side losses. Okay, so you know that the formula that we have in our disposal is 1 minus S into PAG. Okay, so if you know the value of S and if you know the value of PAG, you can easily find the converted power. Now let's find what is PAG. Now what they have given the input power is 60 kilowatts and the total stator losses are 1 kilowatt. So you can clearly see the PAG will be equal to P input minus P stator copper loss minus P core loss. Okay, so these two values together they have given as 1 kilowatt. So this value will be equal to 60 minus 1. Okay, these two values together are given as 1 kilowatt. Therefore, this will be 59 kilowatts. PAG value will be equal to 59 kilowatts. Now we have to find what is the value of slip. Okay, what is the value of slip here? Now how can we find the value of slip? Now you know that 2-3 formulas are there. Slip is equal to N sync minus Nm divided by N sync. Okay, so this is one formula. Do you see that to find N sync, you need 120 into F divided by P. So F electrical is given to be 50 out, but they have not given what is the number of poles. And you don't know the value of speed also. So this formula cannot be used here. So other than that, what formulas we have? You know that FR value is given to be, you have found out to be 2 Hz. And F electrical value is given to be 50 Hz. Okay, so is there a relationship that connects these two? Of course, there is a relation where FR is equal to S into FE, right? That means slip will be equal to FR divided by FE. So this will be equal to 2 divided by 50. Okay, 2 divided by 50, which is equal to 0.04. is equal to 0.04. Now from this we can just put that values here. So P converted value will be equal to 1 minus 0.04 multiplied by PAG, which is 59 kilowatts. Therefore the converted power will be equal to 56.640 kilowatts. 56.640 kilowatts. So this is the, out of the input power which is 60 kilowatts, the power which is converted to mechanical power is 56.4640 kilowatts. If somebody gives you what is the friction and windage losses, you can find the output power then by subtracting this P converted minus P friction and windage loss. If somebody gives you this value, you subtract that from this value, you will get the shaft power or the output power of the induction motor. So with this simple problem out of the way, let us go for the next problem now. So the next problem is that the rotor of a 3-phase 50 Hz 4-pole induction motor takes 120 kilowatts at 3 Hz. Okay. So what they have given? They have given that the rotor takes in 120 kilowatts. That means the rotor input is 120 kilowatts. Or the rotor input is also called the air gap power, right? So air gap power is given to be 120 kilowatts, right? Frequency electrical is 50 Hz, frequency at the stator, and number of poles is equal to 4, and the rotor frequency, it is taking 120 kilowatts at 3 Hz, right? So the rotor frequency is given to be 3 Hz. Okay, and what you have to do, you have to find what is the rotor speed and what is the rotor copper loss. So what is Nm value you have to find out, and what is the P rotor copper loss. So these two values you have to find out here. So let's start the problem. So you know that Nm value will be equal to N sync into 1 minus S, right? 1 minus S. So let's first find the value of N sync here. So N sync is equal to 120 F electrical divided by P. So F electrical is given, number of poles is given. So this is 120 into 50 divided by 4. 120 into 50 divided by 4. And this value will be equal to 1500 RPM. 1500 RPM. Okay. So this is the value of N sync. And what is the value of slip now? To find the slip value, you can use these two relations here. See, there is F electrical you know and FR you know. So FR is equal to S into F electrical. That means S is equal to FR divided by FE. So this value will be equal to 3 divided by 50. So this value is 3 divided by 50. And that value will be equal to 0.06. Okay. So the slip value is 0.06. So we can substitute that here. So Nm is equal to 1500 into 1 minus 0.06. So what is the Nm value you get? It is 1410 RPM. So as I have always told you, whenever you are doing numericals, please do that on your own. See how I am working it out, but always make an attempt that you should do these problems on your own so that you get used to doing all these types of numericals. Okay. So now rotor speed is over, and now you have to find the rotor copper loss. Okay, so let's now find the rotor copper loss now. So you know that once you know the air gap power, the rotor copper loss is nothing but equal to S into PAG. There is a direct relationship which connects the air gap power and the rotor copper loss. So there is S into PAG. So for this particular motor conditions, this value will be 0.06 into 120 kilowatts. 120 kilowatts. So what is this value? It is 7.2 kilowatts. So the rotor copper loss, P rotor copper loss is 7.2 kilowatts. Okay, so that is the second problem over. Now let's go for the third problem here. What they are telling is that for the above problem, that means the problem which we have solved just now, they are telling if the stator copper loss is 3 kilowatts. Okay, so the P stator copper loss is equal to 3 kilowatts, and they are telling that the mechanical losses is 2 kilowatts. Okay, the mechanical loss is 2 kilowatts. So the friction and windage losses they are given as 2 kilowatts, and the stator core loss. Okay, so the P core they have given to be 1.7 kilowatts. So they are telling if these three quantities are given now, what is the motor output at the shaft? They are asking what is the output power or the shaft power of the induction motor. What is this value? And they are also asking what is the efficiency of the induction motor. Okay, so we'll just write down that air gap power how much we got here. So air gap power value was given to be 120 kilowatts, right? And we also found that the rotor copper loss was equal to 7.2 kilowatts. Okay, we'll just keep these values in our hand now here. So now the output power, you know that the output power is equal to P converted minus P friction and windage losses, right? P converted into friction and windage losses. So how to find P converted? So P converted, there's a direct relation, that is 1 minus S into PAG. 1 minus S into PAG. So in the previous case, that S slip value was 0.06, right? So we'll substitute that here. So it is 1 minus 0.06 into PAG is 120 kilowatts. So P converted value will be equal to 112.8 kilowatts. 112.8 kilowatts. Okay. So that is over. P converted we have got, and pre-friction and windage losses they have given to be 2 kilowatts. So we'll substitute that values here. So this will be 112.8 minus 2 kilowatts. So the P output or the shaft power of the induction motor will be equal to 110.8 kilowatts. 110.8 kilowatts. So that is over. So the output power of the motor you have already found out now. The next part of this problem is finding the efficiency. Now efficiency is equal to the output power divided by the input power. Right? It is the output power divided by the input power. So output power you already found out. So we have to find now what is the input power. So you know that the P input power, okay, how did we find the air gap power? So P air gap is actually equal to the input power, there is a formula, input power minus P stator copper loss minus P core losses. So from the input power, if you subtract the stator copper loss and the core loss, you will get the air gap power. So this is the basic relation. So from this you can see P input will be equal to PAG plus P stator copper loss plus P core loss, right? So we know that what is PAG value, 120 kilowatts, stator copper loss we know, and core loss also they have given in this problem. So we can substitute everything here. So we will get this value to be equal to 120 kilowatts plus stator copper loss is how much here? 3 kilowatts. So stator copper loss is given to be 3 kilowatts plus the core loss is given to be 1.7 kilowatts. Okay. So if you sum everything this together, you will get the value to be 124.7 kilowatts. So this is the input to the induction motor. Okay. So you substitute that here now in this formula. So you will get output power is 110.8 kilowatts divided by input power is 124.7 kilowatts. Okay. If you want to get in percentage, you can multiply it by 100. So you will get 88.853 percentage. So the efficiency of this induction motor is 88.853 percentage. Okay. So that is the next problem. So it's a simple problems, all these things, but unless you work out these problems, suddenly when you see this, you might not be able to do the solution. Continuously practice problems, look at the problems what I am doing. Also look at other sources also so that you can widen your knowledge. Okay. Next problem let us take. So they are given a 6-pole, 3-phase 60 Hz induction motor, takes 40 kilowatt input power at 1140 RPM. Okay, so there is an induction motor like this. So this is an induction motor. So this is the stator side. So input power, P input is given to be 40 kilowatts. P input is given to be 40 kilowatts and the motor is now rotating, that is Nm is equal to 1140 RPM. Motor is rotating at 1140 RPM. And what else they are given? The stator copper loss is 1.4 kilowatts, stator core loss is 1.6 kilowatts and the rotor mechanical losses is 1 kilowatt. So you have to find what is the motor efficiency. Okay. So we'll just write down first. A good practice is always writing down what are the given information. That in 10th standard and all, you remember when we were doing the problems, we always used to write what is given, what is to be found out, and then the solution. But as time goes, I don't know what happened, we forget to do all these things, but that is a very good practice to write down what all information is given, so that when you see all this information, automatically what formulas you should apply will come inside your mind. Okay. So the number of poles is given to be 6 pole and the frequency electrical is given to be 60 Hz. Okay. The input power is given to be 40 kilowatts. Okay. And the speed is 1140. Nm is equal to 1140 RPM. Okay. And the stator copper loss, PSCL, is equal to 1.4 kilowatts. And the P core is given to be 1.6 kilowatts. Rotor mechanical losses is given to be 1 kilowatt. That means what they are telling is that the friction and windage losses, which are the rotor mechanical losses, and they might be including the stray losses also. So that is given to be 1 kilowatt. So you have to find what is the efficiency of the motor. Efficiency of the motor is clearly output divided by input power. So it is the output divided by the input power. So input power already they have given 40 kilowatts. So you have to find the output power now. Okay. So the output power is nothing but the input power minus all the losses which are involved in the system, right? So either you can find everything individually, or else you can just find everything step by step. So we will do both. We will just try out both. So the output power will be equal to the input power minus the total losses of the system, right? So the input power is given to be 40 kilowatts minus the total losses. So what all are the total losses? It is the stator copper loss, it is the rotor stator core loss, it is the stator core loss, and also in the rotor side you are having the rotor copper loss, right? So you are having the rotor copper loss here. Okay, so stator copper loss they have given, it is to 1.4 kilowatts, core loss they have given, it is 1.6 kilowatts, but this rotor copper loss they have not given. Okay, so the rotor copper loss we have to find out. Okay, what is it individually we have to find out. So the rotor copper loss will be equal to, you know that one formula that we have is S into PAG. The rotor copper loss will be equal to S into PAG. So if you can find these two values, you will get the rotor copper loss here. Okay, so S value, you can see that the best formula that we can use here, it will be N sync minus Nm divided by N sync, right? So N sync value is equal to, Nm value already they have given, so it is 120 F electrical divided by P. So it will be 120 into 60 divided by 6. So the synchronous speed value will be equal to 120 into 60 divided by 6. So this will be equal to 1200 RPM. So it will be 1200 RPM. And from this you can find easily the value of slip here, right? So slip value will be equal to 1200 minus, what is the speed of the motor? 1140. So 1140 divided by 1200. So this value you will get as 0.05. Get 0.05. So now next is finding what is the air gap power. So you know that the air gap power will be equal to the input power minus the stator copper loss minus the core loss. Stator copper loss minus the core loss. Okay. So this value you can find it to be, so input power is 40 kilowatts minus stator copper loss is 1.4 kilowatts minus core loss is 1.6 kilowatts. 1.6. So the air gap power you get it to be 45 kilowatts. So the air gap power is given to be 45 kilowatts. Okay. So from this, if you want, you can find the rotor copper loss here, and then you can substitute that value here. Okay. But then there is another way to do this, because ultimately you want what is the output power, right? So you know that the output power is nothing but the converted power minus friction and windage losses. The output power is converted power minus friction and windage losses. And this converted power is nothing but the air gap power minus the rotor copper loss. And this converted power you can easily find once you have the air gap power, right? So the converted power, P converted is equal to 1 minus S into PAG. You are having these direct relations. So these formulas are very useful. So this will be equal to 1 minus 0.05 into PAG, which is 45 kilowatts. So from this you will get that value to be equal to 42.75 kilowatts. Okay, so the converted power is 42.75 kilowatts. Okay, so these are multiple ways that you can do this problem. You can either find the rotor copper loss and then you can substitute here, then you will get output power, or you can use this technique which I am telling also. So everything is up to you. So we'll just find the output power now. So the output power is equal to the converted power minus the friction and windage losses. Okay, so this is 42.75 minus the friction and windage. So friction and windage losses, I think they have given us 1. So it will be 41.75 kilowatts. The efficiency is the output power divided by the input power. So this is the shaft power or the output power. So this value will be equal to 41.75 divided by the input power was given to be 48. So it is 48. So there is 86.979%. 86.979%. So this is one way of doing this problem. So now let us move to the next problem. The power input to the rotor of a 440 volt 50 hertz 6 pole 3 phase induction motor is 80 kilowatts. Okay, so they have given that the air gap power, they have given power input to the rotor, right? So they have given that the air gap power is equal to 80 kilowatts. Okay, and it is the electrical frequency is equal to 50 hertz. Okay, and the number of poles is 6 poles. So these are the given information, and they are given the rotor EMF is observed to make 100 cycles per minute. Okay, so we already seen, so in 1 minute it is 100 cycles. rotor EMF is making 100 cycles in 1 minute. So in 60 seconds it will make 100 cycles. 1 minute is 60 seconds. So we want it frequency is in seconds, right? Per second. So in 1 second it will make 100 divided by 60. Okay. So that is the value here, 100 divided by 60. So the FR value will be equal to 1.67 Hertz. FR value is 1.67 Hertz. So what you have to do? You have to calculate the value of slip. What is the slip value as? What is the NM value? And then you also have to find what is the rotor copper loss per phase. So PRCL per phase they have asked. So whatever you are finding will be for 3 phases. So you have to find it for per phase. Okay, so that is the nothing very big in that. So let's first start by doing what is the value of slip. So you know that you are having the knowledge of F electrical and you are having the value of FR also. So you know the FR is equal to S into FE. So S will be equal to FR divided by FE. So this is 1.67 divided by 50. So the slip value will be equal to 0.0334. 0.0334. Okay, so that is the first part of the question. And the rotor speed, NM value will be equal to 1 minus S into N sync. Simple formula. So this will be 1 minus 0.0334. And what is the N sync value? Simply you can easily find it. So N sync is equal to 120 F electrical divided by P. So P value they have given. So it is 120 into 50 divided by 6. Okay, so that value is equal to this value will be equal to 1000 RPM. This is 1000 RPM. So that value we can substitute here. So this is into 1000. So the value is 966.6 RPM. So that is the NM value. The third part is to find the rotor copper loss. Okay, so the rotor copper loss you can find easily now. Air gap power is given. So PRCL will be equal to S into PAG. Right. So this will be 0.0334 multiplied by 80 kilowatts. So this value you will get as 2.672 kilowatts. But this is for all the 3 phases together. So this is for all the 3 phases. So PRCL per phase. Now they have given that this is a 3-phase machine. So per phase it will be 2.672 divided by 3. So it is 0.8906 kilowatts. Okay. So that is this question here. So all the 3 parts we have solved. Now the last question we will take it a little bit of a lengthy question so that we can have an overall understanding of all these concepts. So what they have given, let us see, a 3-phase 230 volt 50 Hertz 100 HP 6-pole induction motor is operating at rated condition. So what is the meaning? Now the output power is 100 HP. Okay, it is operating at the rated condition, remember. So the output power will be 100 HP because this is the rated output power of the induction motor. It is working at an efficiency of 91% and draws a line current of 248 amperes. So the core loss, stator copper loss, rotor copper loss are given to be 169, 12803, 1549 respectively. So you have to find all these parameters. Okay, so we will take everything one by one. So first let us write what is given now. So they have given that the output power, the motor is working at the rated condition, right? So the output power will be the rated power. So that is 100 into 0.746. 100 HP into 0.746 will give it you in kilowatts. Okay, so that is one thing given. So P is given to be 6 poles. And see, this 230 volt, I have told you whenever they give to this voltage here, it is always the line to line voltage. So this motor has a line to line voltage of 230 volt. Don't think that just because they have given it is 230 volt, it is phase voltage. If they have given it like that, that line to line voltage itself is 230 volt. Remember that. So V line is given to be 230 volt. And it draws a line current of 248 amperes. So IL is equal to 248 amperes. Okay. And what all they have given, the core loss is given to be, we'll convert everything into kilowatts. So 1.697 kilowatts. The stator copper loss is given to be 2.803 kilowatts. And the rotor copper losses are given to be 1.549 kilowatts. Okay. So all these points are given. So you have to first find the input power of the induction motor. Okay, so first one is finding the input power. And yeah, efficiency also they have given, right? So the efficiency is given to be 91%. Efficiency is given to be 91%. So to find the input power, you might start thinking that let us find all the losses and we'll do all those things. But there is an easier method to do that because the efficiency is given. Efficiency is nothing but the output power divided by the input power, right? So 0.91, which is the efficiency, will be equal to output power. You know that it is 100 into 0.746 or 74.6 kilowatts divided by input power, and this input power is the what thing you have to find. So the input power from this value, you will get it to be equal to 81.978 kilowatts. Okay, 81.978 kilowatt, that is the input power. And next concept is to find the total losses. Here also the natural tendency is to find stator copper loss, rotor copper loss, stator core loss, adding everything. That is one way of doing it. But then another way of doing is that you know that the input power you know, and you know the output power. You just found the input power and you have found out the output power. The difference of these two will be the total losses of the machine, right? So that is what they have asked here. So the total losses will be the input power minus the output power. So that is 81.978 minus output power is 100 into 0.746. So this value will be equal to 7.378 kilowatts. So this losses is containing stator copper loss, core loss, rotor copper loss, and maybe the stray losses also. Okay, so and mechanical losses. Every loss is included in this particular value, 7.378 kilowatts. Next, what they have asked, they have found we have to find the air gap power, that is PAG. So you know that the PAG value is equal to the input power minus the stator copper loss minus the stator core loss. Okay, so the input power is how much? Where is the input power? Yeah, so it is 81.978 minus stator copper loss is how much? 2.803 kilowatts minus the core losses is given to be 1.697. So this value you can find it to be 77.478 kilowatts. 77.478 kilowatts. So this is the air gap power. So now you have to find what is the internal torque. The D portion is internal. The internal torque is nothing but the induced torque of the induction motor. Okay, so that is easy. So you know that torque induced has two formulas. You know, one is the converted power divided by omega m, or it is also equal to the air gap power divided by omega sink. Okay, so air gap power already you have found out, it is 77.478. So you have to just find the synchronous speed now. So omega sink will be equal to 2 pi into ns divided by 60. 2 pi into ns divided by 60. So the thing is to find the value of ns now. So ns is equal to 120 F electrical divided by P. So they have given, right? So everything they have given. So it is 120 into 50 divided by number of poles is 6. Number of poles is 6. So this will be 1000 RPM. Okay. So we can substitute this value here and we can substitute this omega sink here. So you will get this value to be 77.478 divided by 2 pi into ns. 2 pi into ns divided by 60. 2 pi into 1000 divided by 60. So this value you will get it to be equal to 739.86 Newton meter. Okay, make sure that you make all these values proper. Yeah, one thing that you have to remember here is that now this 77.478 is in kilowatts, right? So if you want to get this in Newton meter, you have to convert it into watts. So forgot to do that. So you have to just multiply this by 1000. So this 1000 is used to just convert this kilowatt into watts here. Okay. So that is over. The D portion of this question is over. So next value is to find the shaft speed of the induction motor. So next is finding the shaft speed. Shaft speed. Shaft speed is nothing but Nm value. So Nm you know that is equal to N sink into 1 minus S. N sink into 1 minus S. So you have to find first the value of N sink, that is equal to 1000 RPM into 1 minus S. So now let us see how to find the value of slip here. There are a number of ways to find the value of slip, but let us see what all we have now. So you know that the air gap power, you know what is that air gap power? That is 77.478. Other than that, you know what is the rotor copper loss also. It is 1.549. Okay. So you have a relationship connecting those two. So the rotor copper loss is equal to S into PAG. Right. So slip will be equal to the rotor copper loss divided by PAG. So depending upon the type of problem and the information that is given, you have to use different formulas available. So we'll just find that value. The rotor copper loss is 1.697 divided by 77.478. Okay, so this value will be 0.0219. Okay, and if you substitute that here, it is 1000 into 1 minus 0.0219. Okay, therefore the Nm value will be equal to 978.1 rpm. Okay, so that is over. It's a pretty long question, I think. So next is the value of power factor. Okay, so let's find what is the power factor. So they are asking what is the motor power factor. Okay, so the motor power factor, what is the best formula that I can use here is input power will be equal to √3 into VL into IL into cos theta. Right? The input power of the motor will be √3 into VL into IL into cos theta. So the input power you already found, it is 81.978 equal to √3 into VL value they have given is to be 230. So don't go and multiply √3 now. The VL itself is given to be 230 volt. Okay. So this is 230 multiply IL was given to be 248. 248 into cos theta. Okay. So cos theta value will be equal to 0.829. Okay. From this, if you calculate the value of cos theta, it will be 0.829. What is the next part of the question? Let us find. You have to find what is the friction and windage losses here now. So what is the friction and windage losses? So that is very easy to find out actually. So what is the friction and windage losses? Okay. So what is the friction and windage? So you know one formula is P output is equal to P converted minus friction and windage losses. Right. So the P output you already know, that value is equal to 100 into 0.746. Okay. That will be equal to P converted minus friction and windage losses. Okay. So how to find the P converted value? So P converted, okay, there are a number of ways to do this. Either you can do 1 minus S into PAG, or you can also use the converted power will be nothing but the air gap power minus the rotor copper loss, right? So we'll use this formula here because in my notes I have used it. So this value will be equal to the air gap power is 77.478 minus the rotor copper loss is 1.697. So this value will be equal to 75.781 kilowatts. Okay. So we'll just substitute that here. So 100 into 0.746 is equal to 75.781 minus friction and windage losses. So friction and windage losses here will be equal to, just subtract these two. So you will get the value to be equal to 1.181 kilowatts. This is the friction and windage loss of the machine. Finally, the last part of the question, if you people haven't slept now, so the last part is finding the shaft torque. Okay, shaft torque. So P shaft. Okay, shaft torque. So shaft torque will be equal to, what will be shaft torque? It will be the output power divided by omega m. Output power divided by omega m. Where omega m will be equal to 2 pi Nm divided by 60. So in this problem, have we found out the value of Nm? Let me just see. So yes, we have found out the value of Nm to be 978.1. So we can just substitute that here. It will be 2 pi into 978.1 divided by 60. Okay. So this value you can substitute. The output power is 100 into 0.746 divided by 2 pi into 978.1 divided by 60. Okay. So this value is in kilowatts. Remember, this output power 100 into 0.746 is in kilowatts. Okay. So that to convert it into watts, you can multiply it by 1000. So then only you will get it in Newton meter. Remember that. So for Newton meter, everything should be in SI units. So watts and all those things should be maintained. So shaft torque will be here now will be equal to 728.327 Newton meter. Okay. So we have done a lot of problems today, around 6 problems, and the 6th problem itself had a lot of subdivisions to that. So with this, let us stop this session, and in the next session we will carry our discussion with torque slip characteristics. Okay. So till I see you in the next video, it's me Varun signing off, and have a great day. Thank you.
Now that the video is over, please stay with me for 30 more seconds. Now the vision of this channel is to create a repository of good quality videos with crystal clear explanation regarding various topics related to electrical engineering. Now if you want to help me spread the word, please share this video with anyone interested in these topics. The second thing is that for me, education is a two-way process. Therefore, if you have any doubts or suggestions regarding any of the videos or regarding the channel, please put them in the comments below. We can have a healthy discussion, and that way we can build a strong community of electrical engineers. So that's it for today's video. So till I see you in the next time, it's me Varun signing off, and have a great day. Thank you.